Welcome back, everybody. We're on Moonstruck right here on Right Radio. Today we're going to be talking about black holes and singularities. And I know in the past few weeks, and actually probably in the show overall, we cover a lot of metaphysical concepts, but I like to kind of get back onto the science track a little bit just for today's episode, where we talk about something that in physics was kind of speculative for quite a while and then eventually was proven. And black holes, it's kind of funny because there's actually this documentary you can look up, and it's under this series called The Universe. It's called Cosmic Holes, and it talks about all the variations of these tunnels in physics, right? You have black holes, white holes, wormholes, which all essentially revolve around this concept of the singularity, which is a point of infinite density where time kind of slows down infinitely. So, but it was saying in this that before black holes were actually proven, there was almost this laugh test that would go on with the physicists, because a lot of them would laugh at the idea that something like this could actually exist, right? So even wormholes, which are not proven yet actually to exist in science as something that is inherently naturally occurring in nature, is actually a solution of Einstein's equations. And if you look into the work done by both Einstein and Nathan Rosen, this is the solution for wormholes. It's actually referred to as the Einstein-Rosen bridge. And the reason why it's called that is because, it was created by Einstein and Nathan Rosen. So that is one solution for a wormhole, which is related to this concept of black holes. But we'll focus on black holes today. And essentially what a black hole is a region of space-time that forms when a massive star collapses under its own weight, and the core becomes so compressed under the gravity. There's so much force that is compressing the inside of that star, and the mass of that star is so great that it forms this black hole, this massive object, which is so dense that not even light can escape. So typically, if you had a star that was of lower mass, it would form what's called either a red dwarf, or basically a dwarf star, or it would also form, if it was a little bit larger, it would form a neutron star, which is kind of this point in between these dwarf stars and black holes. And a neutron star has incredibly strong magnetic field, just like black holes. So this is also kind of relevant just to take note of, that the magnetic force that surrounds a black hole is very, for one, strong, and it actually helps us detect these massive objects in space and time. One of the reasons why we can't actually detect black holes very easily a lot of the time, just when they're not interacting with anything in space, is, it might sound very simple, but it's because they're black. It's because we can't actually see them. And when they interact with masses like gas, or swallow up a star or part of a galaxy or whatever, when they interact with that, we can see in like various spectrums like X-ray or whatever, we can see actually the gas falling into the black hole, into the event horizon. And the event horizon is this region of warped space-time around the black hole, which actually is basically this point of no return. Yeah, we can see it up here on the screen, actually. Thanks for putting that up, bud. And we see that the ring actually around the black hole, where it's very bright, is this region known as the event horizon. And this is where time and space is being warped very extremely right before the point of no return. So it's actually pretty interesting when we talk about what kind of effects occur near this point or region in space-time or relative to the black hole, because there's various things that actually occur around this point. And it's not just a region where gravity is so strong that not even light can escape, which is why the object appears black, but is also a region where quantum effects can occur and be visible around this region. Maybe not visible with the human eye, but or with the naked eye, but we can observe them in various effects or phenomenons such as Hawking radiation. And Stephen Hawking, the famous physicist known for his work on black holes, actually came up with this concept of Hawking radiation based on the concept of what is known as virtual particles. And virtual particles, here, maybe I'll illustrate it on the board. We could keep the picture up. But I'm just going to illustrate here on the board. So here, put it on the other side. So basically here we have these particles that will pop into and out of existence around this edge of the black hole. And these are particles that constantly pop into and out of existence in quantum mechanics. This is what they theorize, that in quantum mechanics, these things called virtual particles pop into and out of existence all around us, but it's very instantaneous. This is constantly happening. They're constantly popping into existence and then colliding with each other. And since they are essentially counterparts of each other, when they collide with each other, they pop out of existence, right? But the concept of Hawking radiation essentially is that because this effect is occurring near the event horizon and near the edge of the black hole, what can happen is that you have this effect where one part or one half of the particle pair, so one of those two particles that I had up on the board, can pass over the event horizon before it reconnects with the other particle. So the particle pairs do not recombine. So then one of the essentially particles will escape into the universe as actual energy. And when that happens, the black hole, because, there has to be this balancing effect, which is, it's actually interesting how we kind of come back to some of these same spiritual principles, like there has to be balance, right? So when balance occurs in this nature, the black hole must irradiate away an equal amount of energy to what has been released when that half of the particle pair escaped into the universe. So the black hole will essentially evaporate and lose mass over time. So this is kind of interesting, actually, because a lot of physicists will ask, and this is called the black hole information paradox. And what it talks about is that when one half of the particle pair crosses over the event horizon and the black hole starts to evaporate over time, what happens to the information or the matter that fell into the black hole, right? If matter or energy can never be created or destroyed in the universe, what happens to the stuff that fell into that black hole? It must be able to contain that information in some form for this law of physics to not be, let's say, broken, right? And essentially what happens is that when the black hole evaporates and, they say what happens to this information, there's actually a book that you can read, and it's called A Black Hole War, which talks about this battle of physics theories between Leonard Susskind and Stephen Hawking, where they kind of debate this black hole information paradox. Essentially, the concept that kind of comes out of this is that the information that falls into the black hole is actually imprinted on the universe in some form, in where the black hole is actually this conduit for imprinting that information on the universe in some other form. And, Leonard Susskind goes into this holographic principle where he talks about how, let's say in a theoretical situation, you are flying a propeller plane up to a black hole, which of course is not possible because there's no air in space, right? But the concept is that if you were in this propeller plane, as you would slow down as you approach the event horizon, and you would notice that little propellers on the end of the main propeller would start coming into existence, or you'd start seeing it, because there would almost be this illusion or kind of time-space warping effect that would come into play, and you would start to see little propellers on the end of all the propellers, and there would be so much until it covers up the whole event horizon, and almost like eventually it would cover the entire universe. But the concept was that because of this holographic principle, the information has to be imprinted in some way in relation to the black hole. So the information that falls into the black hole is not absolutely lost. It can be reconstructed, but essentially, we don't have the capabilities to reconstruct matter from that. We don't even have the ability at this point in time to reconstruct matter from a more simplistic way of it being destroyed, such as, say, you burn something in a fire or whatever, right? An advanced civilization who was able to track the movement of every particle could basically rearrange that matter in the sense where it is back materialized in the same form before it was destroyed. So, in essence, when we talk about this concept of a black hole and how it relates to basically information being destroyed, it's not essentially violating these laws of physics which we have come to build upon. It's just warping them, I guess you could say, in a way where they are very complex to understand in the circumstance. So it is pretty interesting how these black holes occur, and there's three types of black holes. Here we have a stellar massive black hole in this picture. We have a supermassive black hole which exists at the center of every universe, and we have micro black holes which exist or are created in the Large Hadron Collider that exists at CERN. So at CERN, in the particle collider, they smash these particles together and actually creates micro black holes, which are like little singularities, but it's so short-lived that they evaporate very quickly. So that's the basic principle behind those three. And then there's also three variations of the type of movement that occur in a black hole. So there's spinning black holes, there's electric black holes, and then there's spinning electric black holes. And it's theorized, and don't quote me on this to say that this is absolute science that they've proven this, but it's theorized that in certain circumstances, if you had a spinning black hole and you fell into it at the right trajectory, it could act as a type of wormhole in which you could be transported to either another place in space or time, or perhaps even another universe, parallel universe. So it's pretty interesting when we get into these concepts of like multiverse and stuff like that. But yeah, it's funny because for so long in physics, these were kind of like, said to be, oh yeah, that's not something that really exists or that's real or, whatever. But now it is proven, and we can actually like have a coherent discussion about it and say that it's not like, mumbo jumbo science, right? It is actual physics. So, and I think physicists really get excited about these ideas, especially around black holes, because the fact is we just don't know for sure what happens when something eventually reaches a singularity, right, at this point of infinite density in which almost the human mind cannot even comprehend, right? And don't forget, a lot of times, like, we look at the material world, and we talk about this when we talk about spirituality on this channel. We talk about the concept that we see a very finite point in the light spectrum, 0.05% or 0.03% or whatever it is. It's 0.0 something percent, which is very small compared to the whole light spectrum. So we're seeing black holes and akin to this very finite point on the light spectrum. And with that being said, it's just kind of interesting to think that there could be a whole nother world of mysteries which we have yet to uncover. Like if we were able to even, for example, see beyond this 0.05% of the spectrum, right? So physics or mathematics can kind of explain a little bit or give us insight into what may kind of lie beyond this limit that we have on our physiology, right? And it's just interesting because the fact is, like, I think from the beginning of time, humans have been always mystified by things you cannot explain or things that defy comprehension. And, the concept of something that is bending the very reality around it in a way where, the most fundamental aspect of our reality on this planet, light, cannot even escape it, right? And to most of the comprehension of physics, it's understood that light is this almost godly force in the universe. We talk about, like, in spirituality, the concept of light. In the Bible's talked about light. And, when we talk about the angels, we talk about light. And then not even light can escape this massive object. So we're really talking about almost cosmic godly forces here, in a sense, or something that just defies all of reality, right? And our conceptualization of the world itself has to be reshaped in order to kind of understand what is going on near these massive objects, right? So very interesting stuff that we have here. And so what else do we have about black holes today? So we covered the singularity, which is this point of infinite density, and I think I think there's another picture after, right? The second picture. There we go. So here, actually, this reminds me of something that I want to talk about, actually, in the realm of quantum mechanics, specifically in which we talk about these virtual particle pairs. And I think that when we talk about especially consciousness as something that we still don't understand yet, in kind of a parallel to almost how we look at these things in physics, like black holes, you have these particle pairs that constantly pop into and out of existence, which, if you think about the concept almost of entanglement, where, and just to break it down simply, entanglement is this principle in which you could have two particles that are entangled with each other and they're on the opposite sides of the universe. And if I move one pair or do something to one of the particles, the other particle will react in the same way on the other side of the universe instantaneously. Faster than the speed of light, it will react. So when we talk about this concept that is almost defying distance or defying any sense of even how fast light can go, we're really talking about almost this sense of consciousness too, right? When it, like, almost take a second to almost contemplate imagination. If you have a understanding that, like, for example, if you try to imagine something in your head, it's like, boom, the image is there, right? Like, say I'm hungry and I want to, have something to eat, and I imagine a sandwich, right? It's like the sandwich is just there in your mind. You could, like, picture it, right? Very vividly. If I want to write something down, I picture the marker or whatever, right? It's immediately in my mind, right? Almost like the universe understands that there's no lag between space and time, right? There's no lag between like point A and point B, right? They're both entangled with each other, right? In the sense where, okay, if I want to perform this motion or action, like, it's giving you almost, okay, well, I need to do this first, or I need to acquire this, right? So I think entanglement is kind of very fundamental to almost this aspect of consciousness. And when we understand, like, how this can operate in relation to, this object like a black hole, we're really talking about, I would say very complex ideas, to say the least. But Einstein used to say that entanglement, he termed it spooky action at a distance, because it kind of is spooky action at a distance. But if I was able to entangle freely across the universe, I could think myself over to the other side of the room, right? Or you can quantum tunnel like past the wall or whatever, right? And physics says that's possible, that you can do that, right? So when this kind of phenomenon occurs with black holes, in the sense of these particle pairs popping into and out of existence and creating potentials in the quantum field, which is kind of related to a concept that's known as superposition, which is similar to entanglement. We're not going to get into superposition, entanglement, and tunneling today, because that would take up all the time left in the episode probably to cover that. But essentially, spooky action at a distance, let's just term it as that for today. But if you have almost these particle pairs that might lead to the very creation of reality itself, we can get into stuff like wave function collapse and whatnot, where a particle knows whether you're looking at it or not. So almost reality itself is aware of how you are looking at it and what you are imprinting on reality as you pay attention to that aspect of reality. And when this phenomenon occurs in relation to this massive object, it's surmisable that, especially because this is occurring on the outside of the event horizon, or around the border or the Schwarzschild radius of the event horizon, you have potentially this object which can lead to, almost these unseen realities being interacted with, or these unseen potentials rather, in the quantum field. And we know for a fact actually now that black holes could potentially be used for time travel. We know that for a fact. If you were to circle around a black hole for 1 year, you could come back to Earth and potentially like 100 years have passed here. So, that's time travel to the future being proven. And I'm pretty sure I've said that exact line actually before in the show when we had Lon here. I said time travel to the future is possible. So if you're watching this, time travel to the future is possible. So that is scientific fact. And interestingly enough, let me see if I have my whiteboard eraser with me, because I want to actually write down something here that might outline. Maybe I should have brought the mic over. Might outline, actually, we could keep the images up. We could outline so I kind of forget what I was going to outline here. It'll come back to me in a sec. But yeah, we were talking about time travel to the future being possible. Oh yeah, right. Okay, so let's say this line is our understanding of space-time, and let's say that this is what occurs when you have a black hole. I'll put it on this side. So this is almost what happens when you have a black hole. This is what happens when you have the flat space-time continuum as it is. And in between here, this little divot is almost representational of Earth. So this is how we experience time. So this is basically space and time where there's no solar system, no nothing, whatever. There's just empty space, right? So, it's this flexible material which is distorted by mass, as Einstein theorized. Here we have mass, we have the Earth, so it creates a bend in the material. So and I was thinking actually of this on the way here, as I was listening to this, that we essentially, and I've said this before, I'm pretty sure in that exact episode I'm referencing with Lon, that we are actually in almost this little divot in space and time, where we're in this, what physics would call a time-warped field, where there is a little indent in space and time, where it's in between something like a black hole, which warps it completely to the point where you have a singularity, or time just slows down infinitely. But time is slowing down here because it's not here, where time and space are basically one. There's no distance between anything. And here, where we have this little divot, is between this medium where we have this super force of gravity and no force of gravity. So the only thing that's creating time for our perception of it is this little divot caused by the imprint of the Earth on the space-time continuum, caused by the gravitational field. So it's things like this in physics where we have to almost open our minds to the possibility where everything we have conceived of so far might in fact not actually be true, and might be, I say this sometimes to myself even when I attempt to learn something new or pick up a new skill. Forget everything you know up until now, because this is kind of the same methodology of thinking that we have to adopt if we are trying to understand something beyond our comprehension so far, right? And it's really interesting because, when we, use physics, which is, I would say there's almost two schools of thought in between how we look at the world. On one side, you have science, where people say that science is the only thing that explains a physical or natural world. And then on the other side, we have spirituality, which is kind of the ancient conceptualization of how the physical and material world operate, as well as the other planes of existence. And in between there, you have this almost this spectrum, which you're able to explore and basically utilize your consciousness with. And I encourage everybody who's watching this to adopt some kind of variation of their own, where you're not just to the scientific aspect and you're not just to the spiritual aspect, but you're encompassing all the understandings, because then you are stumbling onto a new way of thinking, a new way of understanding the cosmos as it is. So, and I think that comes with one, objectivity, and then two, incorporating your personal understanding into it. So I'm going to put this aside here where we talk about gravity and space-time being bent, but just conceptualize that, though, that the only thing that leads to our experience of time is gravity. If we were, let's say, on the flat space-time continuum where there's no gravity, laws of physics might be completely different. And we might not even know it, because the forces that have been affecting us this entire time as we've been on this planet will not be present. So it's almost like comparing apples and oranges, right? You just have you're trying to conduct the same experiment, but none of the same factors in the environment are present, right? So it's just a new way of looking at things. And with that, if we're going to, pursue these things that, human beings have been coming on to in the past centuries, things like space exploration, whatever, these are things that we should actually take into account. Personally, I believe that, that is not necessary absolutely for the exploration of consciousness, but if mankind is going to that level, it's good to prepare yourself at that level of understanding. So, in any case, actually, I will mention this right before we maybe move on a little bit here, that in various, accounts, people who have been up on the International Space Station have actually reported having almost like out-of-body like experiences when viewing the Earth from that perspective, where they're seeing the Earth actually as something that they're not on anymore. They're seeing it from a third-person perspective. They claim to almost have it's almost like a psychedelic experience for them, or this out-of-body near-death experience, right? And I think that's interesting because even when they're up on the space station, their clocks are running faster on the space station than they are on Earth, because the clocks on Earth are in the gravitational field, so we're experiencing time slower than they are. They're going to the future faster than we are. So, and we won't get into that anymore because it all becomes very complicated when we talk about how objects essentially operate as they approach faster speeds and as they approach the speed of light and stuff like that. So that is essentially the basics of black holes and the phenomenon that encompasses black holes, and in the science area, let's say. So to maybe get a bit more philosophical with it, actually we'll cover one last thing actually before we move on, and we'll go to the other image, the one with the plasma jets. And so here we have this black hole, which is essentially the stream that is coming out of it is called the plasma jet, and is essentially where matter that has been basically swirled up in the accretion disk is actually ejected at near the speed of light. It reaches sometimes up to 99% the speed of light. So this energy is actually ejected from the black hole, and it could be detectable across the universe. But it's just interesting the fact that though black holes are, known for sucking in things, they also expel very large amounts of energy. And one more thing I might talk about in the physics or scientific realm before we move on here is actually this concept of what happens when two black holes interact. And maybe we'll go to the third image now. So essentially when two black holes are in this dance around each other, there's only one in this image, but I just like this image. So essentially when you have two black holes that are in circling motion around each other, what happens is that eventually, one will fall into the other. Usually the smaller black hole will fall into the bigger black hole, but they'll dance around each other and they'll produce these gravitational waves that are actually resonate across the universe and are detectable. We can detect gravitational waves, and these travel across the universe at also near the speed of light. And we can detect almost this cosmic reverberation of space-time that happens as these two black holes almost dance around each other in this majestic dance. But I wish I could draw out the mathematics or the diagram of what happens when these two basically swirl around each other. But essentially they will, the outer one will go up in a movement and go like this. It's almost like if you ever seen the outline of the crown center, the crown chakra, where it's almost like depicted or called the 1,000-petaled lotus, where you have here, I'll maybe draw that because this will be easier to draw out. But it's very similar in the way that it looks when two black holes are dueling or dancing around each other. So, and essentially, this is what it looks like. So it looks like something like this, but in the black hole, it's kind of a bit more. It forms like these loops. Actually, it goes out like this, so it forms these loops in which it goes all around in the same motion, but it's essentially forming almost the same kind of shape, this like lotus almost, as one black hole orbits around the other one, and they go around and around and around, and eventually this gets smaller and smaller and smaller until it approaches the bigger black hole, and then the smaller black hole falls in. So it's pretty interesting, actually, if I do say so myself, in terms of just kind of not even just the physics of it, but just the imagery of it. It's almost picturesque. You're witnessing really magic at its truest form here. And maybe with that we'll kind of move on to the last concept we'll talk about here around black holes, which is maybe looking at it from a philosophical or maybe mystical perspective. We could keep the picture up, and where we just kind of observe or try to contemplate maybe some conceptualizations around black holes, because of course spirituality or works of mysticism would say that we're in some kind of reflective or holographic universe, which science and physics does theorize to a degree. And with that, you kind of are onto this subject of understanding how maybe an object like this, because like solar system itself holds so much secrets, even just of what we talked about with space and time, and the distortion of reality by gravity. But when we talk about really this concept of exiting this maybe holographic universe or the simulation, and energy kind of being encompassed into one true form or force or form of the divine, rather, where everything is coming to this culmination of where it's aligned in this way, or it can almost transcend or reach this almost like hyperspatial state of being, where it transcends to this like next dimension of consciousness, like the afterlife, or whatever lies beyond our perception, wherever people go when they have NDEs, near-death experiences, or OBEs, out-of-body experiences. Perhaps this is almost the cosmos's way of providing us with some kind of dimensional doorway between realms, right? And maybe the reason why we can't see what lays beyond is because everything that we have known up to now, or understand up to now, such as our physical being, matter, conceptualization of the material world, all of that must go, and we must dissolve almost our individuality completely to become one with some kind of higher force, right? And it could be that everything, like if you think about maybe the universe like a box, right? And we're all inside the box, and this whole everything we're experiencing is going on with inside the box, right? And the box is like the universe. Maybe this is like a hole outside the box to whatever lays beyond this box, Maybe there's parallel boxes, and where, Ryan over here is podcaster that talks about, spirituality and physics, but maybe over there he's electrician, or in another universe he's Nobel Prize winning physicist, right? So and the guys behind here helping me in the studio, over here they're producers, but over there they may be mathematician genius, so but we just don't know, right? So but the concept is that over like in these seemingly parallel universes, which is what is termed as the multiverse, there might be other versions of yourself, or other versions of reality that coexist with ours, but have slight variations between them, ever so slight. And that's kind of the whole basis of the multiverse, that every decision you make has an opposite decision, right? So this is like basically the kind of fundamentals of almost we're getting in here to time travel and these paradoxes, right? Even it's talked about if black holes could be used as time machines or wormholes or whatever. This is like kind of coming back to the science, or I guess we're still in the realm of philosophy here, but it's said that if the science of black holes was used to create a wormhole, or used to utilize it like a wormhole, which is basically this tunnel through space and time which connects 2 points rather than leading straight to the singularity, it might lead to various paradoxes which can occur, such as, famous one, the grandfather paradox, where if you were to go back in time to kill your grandfather, then your parents would not be born, and then you would not be born to travel back in time, right? I think that there probably is some kind of safeguards or mechanisms within the universe built in to prevent those various paradoxes from happening, in the sense where, perhaps you could not the possibility would not outline in the field for you to interact with somebody from the past who could significantly alter your destiny in terms of you being able to travel back in time, right? Like, let's not forget, I think one of the principles looked over in circumstances like the grandfather paradox is still the concept that human beings have this electromagnetic field around their body, right? So that's what really causes circumstances to unfold and circumstances to not unfold. And I think that that would probably be a factor in allowing backwards time travel and what could be altered in the time stream. So I'm gonna take a sip of water because I've been talking a lot here. So when we talk about, affecting the time stream or causing some kind of alteration or aberration in the time stream, it could lead to, there's various theories. It could lead to an alternate continuum or an alternate time stream, essentially where if you go back in time to change something, you will end up being the causal factor of that event. Novikov principle of self-consistency, for example, that, talks about closed time-like curves. And then you have a situation more like Back to the Future where, this branching of time can happen where, what was it, like, they travel back to 1984 or something like that, and then they have this whole, like, parallel time stream that is created, right? So essentially, this branching of time could create an alternate, a parallel, wait, how was it said? This branching of time could create a parallel stream, an alternate reality. That's the way I would put it. It would create a parallel stream, an alternate reality. A parallel stream, an alternate reality. And that's pretty interesting because, like, space and time and reality are kind of all these three factors that are kind of all interwoven with each other. So kind of all of them kind of affect the other, kind of like, I'm almost thinking back to an instrument again, like the tuning on an instrument, right? Where you have like, all the, let's say the frets tuned to a specific, like tunage on a guitar, but like then you have also the, they wouldn't refer to it as the pedal. I'm thinking like, piano references here, but the thing, the like up and down thing that they have in the guitar, but like all these factors basically create almost all of this factor of existence, right? So you can almost say like the frets are like, time, or the pedal is like reality or like space, right? So all of them kind of come together to play the music that is expressed by the instrument, right? In any case. So maybe I probably won't draw it out, but I'm pretty sure you get the idea of Novikov principle of self-consistency and these parallel streams. It's based on the concept that various outcomes can occur when you have backwards time travel, which is why it's so paradoxical a lot of the time, right? And kind of with that being said, it's very interesting that something like this can even occur in the first place, and maybe in some sense it's not even you that is time traveling in this specific scenario. Like maybe you fall into a black hole, and again, this is all speculation and philosophy at this point, and this is like not science. Like Novikov principle of self-consistency, alternate time streams, that's science, but kind of just what we're philosophizing about here is kind of all theoretical. But perhaps if you were to fall into a black hole and you get spaghettified, maybe it's not even you in your physical body that moves to this parallel universe, but maybe it's your consciousness that moves to the other universe. So you are now experiencing alternate reality from a perspective of a different you, right? Like you could almost think of it, I know we talked in the last couple weeks about Doctor Strange, Multiverse of Madness, if you ever remember the first opening scene where he's battling the demon and then the other version of himself like dies or whatever, or he gets sucked into the portal and they all fall into that reality, and then he wakes up, maybe it's like that, right? You just wake up and, you think, oh yeah, it was all a dream, right? And then, you have this multiversal traveler come to you and say it's not a dream. Like, dreams are the doorways into the parallel, versions of ourselves or whatever, something along this line. So the fact is we just don't know, right? And I think, again, I've said this earlier on in the episode, I think that's what mystifies physicists about this kind of phenomenon the most, is the fact that we just don't know. So I think black holes are going to be something that intrigue physicists for, many years into the future, perhaps even hundreds or thousands of years. And, if we can get to the point where we are able to unravel the kind of the building blocks that Einstein gave us, right, with these solutions like, the Schwarzschild black hole or the Einstein-Rosen bridge, then we have a stepping stone to something greater, right? Physicists talk about sometimes how, we'll maybe talk about this in a future episode as well when we get into wormholes, is that in 1 trillion years from now, when all the stars are so far away, and this might be after actually the sun runs out, but is that, it's going to be so cold on our planet that basically all life will not be able to sustain itself. And the only way that we can escape that fate is perhaps by traveling to another reality or parallel universe where we can start all over again. And the leading theory for how we might go about this is this mechanism or this object, or phenomenon rather, to use it best, is termed the wormhole. And essentially, they're constantly actually theorizing in physics right now how plausible it is to actually go all the way through one of these things. And it's deeply tied to this concept of black holes, but the difference being that you are essentially creating this bridge between 2 points in space-time rather than just falling to your demise or doom at the singularity. So the difficulty with this at this point in time to, this is the normal space-time route, which might take like 1 billion light years, and this is the hyperspatial tunnel, which might take you like 3 seconds to pass through. So 3 seconds is a whole lot shorter than whatever billion light years or whatever, how long that would take you. And let's not forget, light years are actually a measure of distance, not time. So basically what they need right now, as they theorize, is this thing called transdimensional energy, or negative matter, or negative energy, which is the type of energy that is required to hold open a wormhole and prevent it from collapsing in on itself. So we still don't know how transdimensional energy would actually be acquired to hold open this wormhole. But if we could find a way to harness it, perhaps we can travel to another universe where we can start all over again. So that is the basis of transdimensional energy, and how physics is actually theorizing that we might continue our civilization after the stars run out of energy all around us, and dark energy propels them so far away from us that the light will never reach us. So, but that's like long after the time you and me have here on this planet. Perhaps they're watching this video in the future being like, damn, this guy was onto something, right? But who knows? Could be thinking this guy was crazy. So that's another possibility, right? I'm sure it's out there somewhere in the multiverse. But in any case, that is the basis kind of black holes and wormholes and these hypothetical, wormholes are still kind of theoretical black holes are proven that exist in the cosmos. And, the funny thing is that, like, they say that, miniature versions of wormholes actually might exist all around us that are left over from the Big Bang. So the only thing that might be required is to, hold them open or blow them up with this transdimensional energy. And transdimensional energy actually, in fact, will leak from one universe to another. So if you want to, I know this whiteboard is really getting, I'm really getting my use out of it today. So I'm glad though, because it's for a good reason. So transdimensional energy will theoretically leave, let's call this Earth 1. Let's call this Earth 2. So here, the transdimensional energy will theoretically leak from one Earth to another. And this is kind of the basis of this transdimensional energy, that it flows throughout the multiverse, and that it's possible that this could lead to really profound states of physics being achieved, such as holding open a wormhole, multiversal travel, multi-dimensional planes of energy being interacted with. So that's really all that I have for you today. We covered quite a bit here on black holes and wormholes and time travel and paradoxes and quantum physics. So I didn't think we would get all of that in one episode, but surprised enough to see that, here we do the impossible as well. So, So this is Moonstruck right here on Riot Radio. I hope you enjoyed today's episode on black holes. Perhaps next week we'll come back and cover wormholes. We didn't cover white holes today, but perhaps we'll get into that in the future. If you are interested in looking up that idea, the basis is that it's just matter being ejected from a singularity rather than falling in. But again, this has been Moonstruck right here on Riot Radio. I'm Ryan. You can follow me on Instagram at @top_sorcerer. I encourage you to like and subscribe if you enjoyed this episode, because it really does help support the channel. Follow us on DC Media Hub, so you can catch and stay up to date with all the episodes on Moonstruck, as well as if you are engaged in this type of concept and you want to learn more about these kind of concepts or ideas, even in a shorter format, you can check out my other channel that is titled Sword of Mercury, where I get into this and I outline it on the whiteboard in maybe a more actively entertaining manner. So it's less kind of lecture format. In any case, I encourage you to help support those channels because it does help out. So again, this has been Moonstruck right here on Riot Radio. I'm signing off, and I'll catch you next time.